Hi everybody, my name is Neil Woodfine. I'm the Director of Marketing at Blockstream. So today I'm going to be talking about using Bitcoin in offline environments. But first, I think it's probably a good idea to give you a quick introduction to Blockstream. I think a lot of people are probably already familiar with us. Okay. Blockstream is a Bitcoin infrastructure company. We build a lot of things that just make Bitcoin better. But we do have some commercial projects as well. So our main focus is on the Liquid network, which is a sidechain for traders and exchanges. And it basically allows traders to send faster transactions in a more private way. We also have a Bitcoin wallet, Blockstream Green, which supports Liquid. And we just recently announced Blockstream Mining, which is a project providing enterprise-grade facilities for the co-location of mining farms. So we have people like Fidelity, Reid Hoffman, the founder of LinkedIn, working with us, and a bunch of other large corporations hosting their miners with us. So these are kind of like our big corporate projects, but we also work on a lot of underlying infrastructure technologies, which aren't specifically commercialized yet, but make Bitcoin awesome. So one of those is Elements, which is an open source sidechain and blockchain platform. So if you're ever interested in spinning up your own sidechain like Liquid, you can use Elements to do that. And that's based on the Bitcoin code base, so it's very easy to develop in. We do a Lightning network implementation called C Lightning, which is optimized for performance. And we also have a collaboration with the Intercontinental Exchange. They're the owners of the NYSE, and we provide cryptocurrency data for them. And then another one of our projects that a lot of people have heard of is Blockstream Satellite. And that's what I'm going to be talking about today, in addition to some other kind of complementary technologies which help us use Bitcoin offline. So before we talk about particular solutions to using Bitcoin offline, I think it's probably good to answer the question, why on earth would we want to use, I mean, the internet's great, right? Everybody's got it. Well, I've said this before, that Bitcoin is as much a hardware revolution as it is a software. Everybody thinks it's like kind of money as software, right? This is great. But actually, hardware is integral to making the whole system work. So everybody knows that not your keys, not your Bitcoin. So if you don't have control of your keys, you don't have control of your Bitcoin, it's not yours. Don't keep your funds with a custodian. But in addition to that, it's also not your hardware, not your node. Or for example, if you're holding your keys, you have to hold it on hardware that you have control of yourself. And the same with a node. So if you're using like an Amazon cloud server to host your node, you're not really in control of that verification process. At any time, your cloud network provider could have a catastrophe and you'd be disconnected from your node, or they could change the software running on there. So it's really important to keep control. Well, like an extension of this is not your network, and I couldn't think of a catchy enough one for this, so not your network, not your Bitcoin network. At the moment, we're all completely dependent on our internet service providers for access to the internet. And we're not really in control of the network. And some of these offline solutions actually put the control back in our own hands. So ways that we can see this in action, why having your own internet is important. So you might have a lack of internet entirely. The cost of internet might be high. You might want redundancy in case things go wrong. And privacy. There's also a lot of kind of unintuitive privacy benefits from using non-internet options when using Bitcoin. So the first example is lack of internet. If you're in a remote location, for example, a desert, that's maybe a bit of a silly example, but there's a lot of kind of developing economies with remote villages where they don't have access to the internet. One of my friends, Michael Dunworth, just sent me a tweet a few minutes ago saying that internet penetration is only 52% of the world population. Like, there's a lot of people that don't have access to the internet at all. If you're on an island or if you're in the mountains, you may have some very strange kind of use case where you need to use Bitcoin. Well, offline options provide a solution to that. Cost of internet. So we're really spoiled with internet access in developed economies. We have very, very cheap broadband connections. They're getting cheaper every year and faster, but that doesn't apply to the entire planet. There's a lot of people that, especially in developing economies, that don't have these great internet connections. And they're kind of, this problem's compacted by the fact that their internet connection is not great, it's expensive, and then in addition to that, their wages are often, on average, quite low. So that means that these people can't support some of the bandwidth requirements, for example, to use a full Bitcoin node. And so we can see this, an example of this in node maps. So people have tried to kind of geolocate some of the more public Bitcoin nodes. I took this earlier today, and you can see Europe's doing great. The US also doing really well, China, Japan, some good node participation there. But if you look at places like Africa, South America, there's very little node participation, and part of the reason for that is because the internet is so expensive, and the infrastructure there isn't as good. These places need Bitcoin as much as we do, as anybody else. And in some cases, they need it more because they often have weak currencies that are getting overinflated. It's really important that they also have the option to access the Bitcoin network if they want to use it. And if they want to use Bitcoin, they should also use it in a trustless manner where they're using a Bitcoin full node. Otherwise, they're kind of like second, third-class citizens on the Bitcoin network. So the third reason for offline Bitcoin is redundancy. So most people only have two internet service providers. They have their home broadband, and then they also have their mobile cellular contract. Often, both of these contracts are provided by the same company. And so as we become more and more dependent on Bitcoin for our kind of financial lives, we have these like a very small number of centralized parties that are providing access to these services. So that kind of creates a little bit of a single point or a few points of failure. And another reason why kind of having redundant options is really important. If you're a merchant or you're a miner, it's essential that you stay connected to the network, otherwise you can't receive payments from your clients, or you can't see the new blocks coming in. You could be losing like thousands, millions of dollars worth of Bitcoin per day. So that's a real big risk. And also you need to make sure that you're connected to the wider network, so you've got a global view over which Bitcoin chain has the most work applied to it. So examples of specific threats that might mean that you need some redundancy for your Bitcoin network access: infrastructure failures, natural disasters, and intentional outages. It's a little bit of a euphemism. So infrastructure failures, already seeing that even in developed economies. So California is going to switch off its power, which you can guarantee is going to affect some of the internet infrastructure. People don't have a choice about this, it's just going to happen to them. If they're completely dependent on Bitcoin, that would become an extremely big problem for them. They wouldn't be able to transact, they wouldn't be able to buy supplies, that kind of thing. Now, I live in Thailand. I work remotely for Blockstream, and my internet connection quite regularly goes down. I mean, it's great, it's cheap, it's fast, but it quite regularly gets disconnected. We had a storm recently, and both my cellular and my broadband went down for a few hours. I tried to go to a 7-Eleven to buy some water, and they'd be like, we can't sell anything, we're disconnected. So like, this is a perfect example of why these offline solutions are really useful for providing redundancy. Another example is natural disasters. Hurricane Sandy knocked out a bunch of internet infrastructure in the US. There's earthquakes, all these kind of threats. And then intentional outages, you also have the threat of kind of corporate or political action being taken against networks. We saw in the Arab Spring, people were having the internet switched off on them, and they were having to resort to using SMS to get tweets out and stuff like that. I used to live in Xinjiang, China, and a couple of years after I left, they had some terrible riots there, and the internet was switched off for half a year, 6 months, just totally gone. And in that kind of situation, like, I mean, if we live in a kind of a Bitcoin, hyper-Bitcoinized world, that's going to cause some serious problems for people's kind of businesses and transactions. And yeah, so like even like developed economies, which we consider to be more free and democratic, unfortunately, we're also starting to see kind of certain actions being taken. I mean, I come from the UK, and we already have like the Great Firewall of Great Britain, where certain increasingly more amounts of information are being censored from domestic internet. So there's potential threats there too. And these instances of governments taking action against internet connections and censorship is increasing. Governments are becoming more and more confident and more sophisticated with their ability to filter certain traffic, filter certain activities online. And so the other benefit of using offline services is privacy. So at the moment, we have ISPs that have pretty much access to all of the data going in and out of your home. If you're using a Bitcoin full node, that is using quite a lot of data. It's quite kind of obvious to anybody that's really kind of looking for it that you're running a Bitcoin node. And as well, if you're connecting to other nodes just without Tor in normal kind of Bitcoin node operations, you're also announcing your IP address to others. So you have like potentially your ISP and other Bitcoin node users all knowing your IP address, and your IP address can be traced to your physical address. Your physical address can be traced to you and your family, and you've kind of announced to these people that you have Bitcoin and you're kind of keen about Bitcoin enough to be running a full node. So it's potentially dangerous information. So exactly the same kind of process that was gone through to geolocate these nodes can also be used to locate your node. So before we talk about some actual solutions, I think it's good also to look at some of the challenges in creating offline Bitcoin transactions and offline Bitcoin node operation. So first problem is that we need to get transactions to the miners. Otherwise, they're not going to get mined onto the blockchain. Like, no transaction has taken place until that gets there. So what that means is actually these kind of offline internet-free options are not really internet-free. They're internet minimized. So we're trying to minimize the amount of internet that we need, but ultimately at some point we need to get that transaction onto the internet so it can be transmitted to a miner. You could technically maybe like kind of put on a USB drive and like give it to a miner and be like, mine that for me, please. But that's not scalable. So ultimately we need to get the transactions to the internet. Another challenge is that ideally these solutions need to work in low power environments. Because often the internet outages are going to be accompanied with power outages. So you need to be able to run on battery power or a generator if the outage is longer. And yeah, so the other big challenge is node bandwidth requirements. You're probably going to need 10, 20 gigabytes per month just for maintaining the downloads. If you're uploading, you're going to need another 200 gigabytes. These bandwidth requirements are quite high, and particularly high if you're looking at developing economies where they may only have a few megabytes per month. But one thing that we don't have to worry about, one thing that is absolutely not a challenge, is transaction data. Transaction data is less than a kilobyte for a regular transaction. You don't have to worry about, like, there is no stopping that data. That's a tiny amount of data. This kind of data just wants to be free. Like, you can get that wherever you want it. This doesn't pose a challenge to offline solutions. So, talking about some of the actual applications. The first one is Blockstream Satellite, which comes from the company that I work for. The first step to facilitating offline Bitcoin usage is operating a Bitcoin full node. because we need to be able to trustlessly verify that we're actually receiving these transactions, and the transactions are conforming to our own protocol rule set. This is where Blockstream Satellite comes in. Just kind of as a super high-level description, it provides a one-way transmission of Bitcoin blockchain data, and it allows users to operate a full node completely without the internet and do their own transaction verification. How that works is, first, Blockstream provides Bitcoin blockchain data to teleports on the ground, and they transmit the signals up to the satellite network. So we have 4 satellites in geosynchronous orbit around the Earth, and what that means is they're basically traveling around the equator at the same speed that the Earth is rotating. So they stay in the same place in the sky all the time, and it works in the same way as your kind of TV, satellite TV. If you have that, it works in the same way. And with the 4 satellites, 5 transponders, we managed to get pretty much almost global coverage of the land mass on the planet. And so you can see there the coverage map. There's areas that we don't get. For example, Greenland. There's an unfortunate sliver down there of Eastern Europe and the Middle East, but everywhere else is covered. We also can't get the poles, because if you're using geosynchronous satellites, they just can't get there. So that's kind of dealing with the transmission, beaming it down. Those radio waves are probably going through us right now. But how do we pick them up? So what you need is just a really basic set of equipment, which you can probably buy for under $100. You'll need a satellite dish, same as you use for picking up TV signals. You're going to need a computer, but the requirements are super low now. The last year, the engineers at Blockstream have been working really hard on optimizing the software, so now you could do it on a Raspberry Pi or a Rock64, no problem. And then also a kind of specialized piece of hardware called an SDR. You can pick that up on Amazon for like $24. And that's it. You set it up. Directing the dish is a little bit difficult. You're going to spend quite a few hours getting that right, because like even a little millimeter is like a few miles in the sky. But yeah, you set that up, connect it up, install the software, and you can start running your Bitcoin full node entirely without the internet. And so the benefits, kind of, this is going back to some of the problems that we discussed before. For internet availability, regardless of where you are in the world, as long as you've got like kind of a clear view to the sky, top of a mountain, in the middle of a desert, no problem, you're getting your Bitcoin blockchain data. It's totally free to use, so if you've got very expensive broadband plans, if you're only using a feature phone or something like that, like you don't have a whole lot of data, no problem, totally free. You don't need to register, no subscriptions, no bandwidth requirements. You're getting all of your Bitcoin data for free. And then redundancy, so if your internet connection goes out locally, doesn't matter, you've got your satellite feed. This is especially useful for merchants, miners. If you're an institution that depends on being able to verify your transactions, it's good to have kind of redundancy options. A lot of like, for example, miners are based in remote locations in China, and they'll have like 2 internet connections. But even those 2 internet connections in these remote locations are sometimes pretty sketchy, and they can both go out at the same time, and then now you're losing a lot of money. And then for privacy, it's great, because it's a passive, you're passively receiving the data. Nobody knows that that data is arriving at your dish and being processed on your computer. And the satellite dish just looks like a regular TV satellite dish. So like, there's no way of anybody knowing you're running a Bitcoin full node. But let's say like people start looking out for these things, you can kind of put it away from the street and make it non-obvious. So the satellite is really good for supporting the operation of Bitcoin full nodes in these offline environments. And just this is a really super basic diagram. You might be wondering why I'm showing it to you. We're going to be building on this later with all of the other additional options that we can add to this. But yeah, completely at a simple level, that the Blockstream satellite is providing the blockchain data. This computer can be disconnected from all other devices, and it can still see the entire blockchain and verify any incoming transactions. Where they're going to come from, we're going to look at that later. So just before I finish on the satellite, another one of the really cool services that we provide through the satellite is the API. So we don't just beam the Bitcoin blockchain data down from space, we also provide user data. So anybody here, if they like, can go online and start transmitting their own funky messages and send it to the entire planet via the Blockstream API. And one of the cool things we've done is we've combined this with our Lightning research. So these messages are very, very small and short and like don't cost a lot of bandwidth for us. So like charging high fees is not required, but we'd like to like kind of recoup some of those costs. So we're using microtransactions to pay for each one of these messages, and Lightning's a perfect fit for this. If we wanted to use Bitcoin transactions, the fees would be too high. If we wanted to use like credit cards or something like that, then again, the fees would be too high. Lightning fits the bill perfectly. So if for any message that you send out, you bid on it. There's kind of an auction to get messages out faster and slower, and you can do that with Lightning. And so we've had some really cool experimentation going on. This is something from very early on after launching the service. We don't know who this is. It was a mysterious guy writing a journal. There was much more after this, but still hard to grasp the fact that I'm blanketing a big part of the Earth with my message on demand instantly. I'm wondering, does anybody reading this message, maybe a portion of the photons are missing the Earth and traveling in space for billions of years? It's pretty cool, the kind of stuff we can achieve with Bitcoin. And then also, this is an unofficial feed of the Blockstream satellite transmissions. So somebody's set up a feed that kind of repeats the messages, but on Twitter. So if anybody is a Twitter user here, you can go online and see what people are sending. I mean, there's a good few messages every hour. I took a family-friendly section of the Twitter feed. You can check out the rest yourselves. And finally, some key notes about the Blockstream satellite. It's one-way, download only. A lot of people kind of get confused and think you can start beaming transactions back up to the satellites. You can't do that yet. It's just for operating a Bitcoin full node. The initial sync requires the internet. So the bandwidth requirements, like we saw for initial sync, it was 200 gigabytes. You're going to need to do that through an internet connection before connecting to the satellite. And then also the transmissions are transmitting the last 24 hours of blocks, I think on like a 6-hour cycle, which means that if your device gets disconnected or whatever, you can catch up pretty quickly. And one thing that a lot of people kind of jump to a conclusion, like, this is a really trustful service. Like, we're trusting Blockstream to provide the blockchain data. What happens if they kind of mess around with it? But if you think about it a bit longer, it's actually not as risky as you might think, because the data provided by the satellite is already verified. Like, it's had the proof of work applied by the miners. If we started messing around with the data, the proof of work would go down significantly. All the transactions are verified. Like, nobody can move a UTXO without their own private key. And then also, in addition to that, you can do your own spot checks for the data you're receiving. So you're receiving the full blocks, but like, you can use a separate service to check the block headers match. So you can use a kind of a spot check with a secondary source. And you can do that through all sorts of other non-internet means. So we're going to talk about a few of them now, but like mesh networks, SMS, or even radio transmitted block headers. You could technically, potentially include a signed message within the satellite transmissions themselves, signed by a third party with the block headers. I haven't thought about that one long enough, so that one might not work. Okay, so that's the satellite done. One cool additional thing we can do with a satellite full node is rebroadcast the blockchain data via Wi-Fi. So all this takes is one additional piece of equipment, which is just a really standard piece of Wi-Fi hardware. And yeah, you just switch it to AP mode. and then you can start broadcasting over Wi-Fi to your local area the blockchain data that you're receiving from Blockstream satellite. And what that allows you to do is, if you've got a community that everybody doesn't want to buy the satellite dish and all the hardware, all they have to do is have a Wi-Fi router, and they can receive that blockchain data from you and run their own full node according to their own software. And there's there's applications you can build on top of this. So you could run your own Explorer, Block Explorer, which people can access via this Wi-Fi access point. So they can start searching blockchain data themselves. They could run their own Electrum personal server to use with their hardware wallet and start transacting that way. And then if the Wi-Fi point is connected to a mesh network, which we're going to talk about in a second, these kind of Wi-Fi subsidiaries can start sending transactions through the mesh network and onto the internet. So it allows kind of a local community to start transacting amongst themselves and running full nodes. This is super cool. Grubels he's helped me a lot with preparing tonight's presentation. He's the satellite technician at Blockstream. He has the best guides for setting up any of this stuff, offline transactions, satellite setup guides. So I'd really highly recommend you check out some of his materials online. But this is one of the little kind of projects he did, which was creating a little mobile Bitcoin service provider. So you could drive your car anywhere and start providing Bitcoin full node services to the area with just a little bit of hardware, which is pretty cool. So just a little update to the diagram. So we had our sat node. But now we've got some additional people which are also using that in this sat node's local area. But we still haven't worked out the Bitcoin transaction section. We don't know how to get them out, and we don't know how to start transacting between each other. So the answer to that is, well, one of the answers to that is mesh networks. So just a really kind of I think most people will probably guess what a mesh network is, but it's just a network of nodes directly connected to each other. Every node is connected to every other node in range. All the nodes relay information that they receive, so they're kind of friendly and passing on information to each other, probably encrypted. It's not centrally owned. Nobody owns the network. Nobody can control it. So going back to that earlier slide where I was like, not your network, not your network, this is definitely your network. People own it. But one thing to bear in mind is these mesh networks can only go so far. So in a city or a suburban area, you're probably okay. You can kind of build a network. But as soon as you want to start like Switzerland communicating with China or something, you would have to have a very, very long mesh network. You would have to have a lot of hops. It would be very difficult. So this is essentially what you would call a last mile solution. You really want one of these nodes in the local vicinity to be connected to the wider internet to start passing information around. Or you could connect them to other information hubs like SMS or something like that. So the first option with mesh networks is GoTenna. They have a device called the GoTenna Mesh. It connects to your laptop or to your mobile device via Bluetooth or USB. It has a 6-kilometer range. That's like in kind of a good environment. Like if you're in a city, it's probably going to be a lot lower than that. You can do a maximum of 3 hops. So with the 6-kilometer range, you're looking at about 18 kilometers from end to end. It's got a battery in it, so you can use it outdoors and travel with it. It's fairly expensive at the moment, but this is the first iteration. You can get a discount on that with the TX10 code. Recently, we did a collaboration with GoTenna to update their TX10 software to be compatible with Blockstream Satellite. So it works together really seamlessly. So what that allows you to do is have your satellite node, and now you can start sending transactions out from it using your GoTenna. And it's supported across desktop and Android. No iOS at the moment, unfortunately. And again, this is last mile technology. So this only kind of gets us so far. This is a map of the US. People might be wondering, like, is anybody actually using this? Is there any mesh networks? In the US, they're doing pretty good. I think there's at least one city that's decided to kind of distribute these among, I think it's local businesses or local people, for kind of disaster preparedness in case of any kind of internet outages. Yeah. Unfortunately, that's Switzerland. So I've heard that you guys have nuclear bunkers, so you obviously have a tradition of being prepared. I think you guys need to work on this as a priority. I hope this video works. Oh, great. Yeah. So this is a video by Grubels of a transaction. So basically, this is a satellite node, and he's created a transaction on the satellite node, converted it into a QR code. He's going to scan it with the TX10 app, and then that's going to send it to another TX10 relay. So when it completes, that's basically the message that you get. It's been relayed to the mesh network. That's going to go to another GoTenor and maybe another GoTenor, and that GoTenor is going to be connected to the internet, or it's going to have SMS, and then it's going to relay that transaction onto the internet so that it can be mined and go to the blockchain. And then as soon as it's mined onto the blockchain, it's going to come in via the satellite node, and he's going to see it. In addition to that kind of confirmation through his own node, he'll also get notifications through the TX10 app that, one, the transaction's been relayed to the internet, and then two, that it's been confirmed on the blockchain. You can't really trust those messages. It's not a trustless system, but it's nice to receive those. So that was GoTenors, and that's got a full integration with Blockstream Satellite, so it's good to go now. One more experimental technology that exists today is LoRaWAN. This is really popular in the maker community. I've heard, I'm not a maker myself. It's used in a quite popular network called the Things Network, I think. So basically, people that are working on IoT are trying to connect together all of these low-powered devices, and LoRa is really good for that. So LoRa stands for long-range wide area network. And it works on super low-power devices. It's got a similar range to the GoTenors. You can use it in low-power environments, but you can only transmit very, very small amounts of data. This has got a really kind of like strong developer community around it. It's an open standard, an open protocol. So I think this definitely shows a lot of promise. Unfortunately, there's not a whole lot of people working on it in Bitcoin right now, but I think it could turn into a really interesting solution. So updating the diagram even further, we can really start to see a resilient Bitcoin network starting to form. So we've got the guy running his Blockstream satellite, fully verifying all of his transactions, helping his local community to do so too. And now with the ability to send transactions via our GoTenors, we can now relay those to other people and also to internet-connected nodes, so they can transmit those that blockchain transaction data to the internet. I mean, you could create much bigger networks with this. I've just tried to simplify it to make it easy to understand. One thing to note in this is that we only have one device connected to the internet. All the others are disconnected, and they're using Bitcoin, they're transacting, they've got full nodes. Yeah. So one final thing to look at more closely is SMS. So we mentioned earlier that Bitcoin transaction data is super small. It's slightly longer than the kind of average. I think it's 140, 160 characters. But what we can do is just break up that transaction data into a few SMS to send out. And we saw this happening in the Arab Spring. People were sending out communications like tweets and stuff. I think even that got blocked, and then they started using voice call and kind of dictating the tweets to send out on the internet. Or you can use SMS in the same way with Bitcoin. Yeah, you can basically what you would do is make your Bitcoin transaction to somebody, get that transaction data, send it as an SMS to an internet-connected relay that would receive the multiple SMS with the Bitcoin transaction data, put it back together, and then send it to the internet. There's already multiple solutions for this. So TX10 supports it already. So you can use that in conjunction with GoTenor. Also, Samurai Wallet, who they produce a Bitcoin wallet on Android, and they have a solution called Pony Direct, and that also allows you to send SMS. And then Pavel Rusnak, who is the CTO of Trezor, he started investigating this very early, and he also has an application called SMS Push Transaction, which basically cuts up the transaction into parts, sends it via SMS, and then repackages it at the other end. And so, finally, looking at kind of this network that we've created, all offline. In addition to what we discussed earlier, we have the mobile wallet at the top, which is now also able to transmit transactions that are made over here via SMS and onto the internet. And then the SAT node at this end can verify that those transactions took place. And this is super simplified. It doesn't kind of visualize all of the extra hops we could do with the mesh network. And it also doesn't depict all of the other offline options. So as I was preparing for this talk, I was only planning to talk about satellite and GoTenna, but I did a bit of extra research, and I didn't realize actually how many offline solutions there are. So in my introduction, they mentioned that like people have been thinking about this. A lot of people have been thinking about this. So just really quickly, some honorable mentions of some of these extra solutions for offline Bitcoin transactions. You have OpenDime. I'm a big fan of these. These are super cool. So you have something called SneakerNet, which is an offline solution, which basically means carrying data while wearing sneakers across borders, from place to place, anywhere that you don't have a connection. So you can use like physical media, you can use USB sticks, but Rodolfo Novak has created something called the OpenDime, which allows you to put Bitcoin on a device and know that nobody can spend it until they've broken one of the little kind of holes in it. And it's basically a trust minimized way of creating a bearer asset of Bitcoin. So we can use that to move Bitcoin around in an offline environment. Amateur radio. There's a whole kind of, there's a lot of resources online about using Bitcoin with amateur radio. There's a really, really good talk from Magical Crypto Conference by Rodolfo Novak, so I'd recommend everybody checks that out. I'm going to post some resources at the end of the talk. But that basically allows you to transmit Bitcoin transaction data to the entire world with very low power equipment. Technically, you require a license to transmit radio, but I think if you're in a kind of desperate situation, under a bad regime or in an emergency situation, I don't think many people are going to be caring about licenses. In addition to that, it's very difficult to pinpoint where these signals are coming from. I think people have probably heard of number stations, also have this, this issue. Basically, you're bouncing the signals off the stratosphere, so it's very difficult to triangulate where they're coming from. Another really useful option is Iridium Go, which is another satellite option, but it's bidirectional, so that now we can send data. Again, it's low bandwidth, but it allows us to communicate data to the wider network. And then another one that we get asked about quite a lot is, like with the Blockstream satellite network, why are we not just using CubeSats? They're much cheaper. The problem with CubeSats is that they have a very short lifespan. I think it's like a year, 2 years before their orbit decays and they crash down. And another really important problem is they rotate at a different speed to what the Earth is spinning at. So what that means is that they're moving in the sky all the time. So you kind of got to direct your satellite dish. You got to constantly move it, and that requires like expensive equipment for receiving those signals. Some useful tools. So we've talked about different channels, different mediums for using Bitcoin, but there's also some useful tools that you can use for offline Bitcoin usage. So one of them is Blockstream Explorer. So we have an open source Explorer which you can access at blockstream.info, and that has a really neat little button which is send transaction. So you can just get your raw transaction data, put in there, press a button, and it's transmitted to the Bitcoin network to be added to the blockchain. It doesn't have any tracking, no Google Analytics, anything like that. And also, it's based on an open source code base called Explorer, so anybody can set up their own Explorer and use these features. So for example, Bitcoin Magazine, their Block Explorer is using Explorer. Another really promising technology for use with offline Bitcoin transactions is PSBT, partially signed Bitcoin transactions. It provides a really nice standardized way for us creating multi-sig, like incomplete multi-sig transactions and passing those around on these offline networks. And there's one really cool trick that Rodolfo Novak talked about at MCC, which is incentivizing relays. So at the moment, in these mesh networks, you kind of just have to hope that these other nodes are going to relay your data onto the internet. But if you want to incentivize that kind of behavior, you can actually create, with PSBT, you can create an additional transaction, an additional output on your transaction to a private key, and then make that private key public. So you kind of transmit you transmit the way to send the Bitcoin to a place where somebody can spend it immediately. And what that does is it allows the relayer to send your transaction, but at the same time, their transaction is packaged up in that, and they can send the Bitcoin to their wallet and make a small relay fee, which is pretty cool. And then, yeah, Samurai Wallet is integrated with TX Tenor, so that's really good for using in these offline environments. And then Groobles has also produced a Python script which allows you to hide Bitcoin transaction data behind a string of words. So basically you encode it, and it's just kind of random words. It's very difficult for anybody to see that it's actually a Bitcoin transaction. And then at the receiving end, all they have to do is decode that, and it turns it into a raw transaction again, which you can then upload to the Bitcoin network. So that's for kind of more covert transactions. Some of the things that we can look forward to, Blockstream Satellite is going to have a really big, exciting update soon. I can't say what it is yet, but if anybody's thinking about setting up their own satellite node, be aware that you're probably going to have to update one or two parts. It won't be super expensive, but just bear that in mind. And then also, in conjunction with this update, we'll also start releasing satellite kits to make it a lot easier for people to get started on using the network. LoRaWAN, I think that looks very promising to me. Valerio Vaccaro is working on that, so I think we're going to see some progress coming from that soon. And then just one thing to bear in mind is that all of this technology is super. I mean, Bitcoin's only been around for 10 years, and these offline solutions are maybe only like 2 or 3 years. So I think we can expect them to develop and improve much faster. Now they're a little bit clunky. They need you to be a bit of a hobbyist to use them, but they're going to get better, in particular the UX. So I'm pretty much getting to the end of my talk here. Maybe some people in the audience are thinking that the people working on these solutions are being a little bit paranoid, and maybe they should be wearing tinfoil hats. But the point of Bitcoin is to think of these kind of edge cases, think of to expect the unexpected. That's why Bitcoin exists. We have to make it super resilient to all potential eventualities. And so creating these offline solutions is part of that process. And we're already starting to see kind of threats being posed to Bitcoin in the form of kind of Chinese censorship, UK censorship even. Encryption bans are being discussed in quite a lot of developed economies. Encryption is potentially way more fundamental and kind of outrageous to be banning compared to Bitcoin. So we need to kind of prepare for kind of bad things to happen. But aside from these kind of censorship resistant things, we take for granted the internet. These offline solutions are probably more about participation. People in developed economies also need to use Bitcoin and often don't have great internet connections. So these provide ways for them to use Bitcoin and use Bitcoin in the right way. We can say for certain now that Bitcoin is not reliant on terrestrial internet. Already with these few solutions, we have alternatives. I think if there's ever any network disruptions anywhere, whether it's a natural disaster or a government intervening, we can always route around them. And finally, a bunch of small print resources. I'll be sharing this deck with the organizers and making sure that everybody has access. There's some really, really good videos here. I'd highly recommend checking them out. And if we have time, I don't know how long I've been talking, but I can answer some questions if anybody has any.
Hi. I was wondering, does Blockstream own this satellite?
No. So we've made an effort to make sure that we're using multiple different satellite companies so that we're not dependent on one. But no, we don't own the satellites. We have a contract with the satellite providers.
So I'm curious, what's the cost of operating the service, and who pays for it?
That's not information that I'm privy to, so I can't answer that one. I'm afraid.
I imagine that at Blockstream you guys talk about nation-state actions that would warrant this type of decentralization. So can you talk us through some of your scenarios where nation-states are taking actions to break up the internet and disruptions?
So I think we've already mentioned a few of them in the presentation. I used to live in China. I lived in China for a long time, and it's getting much more aggressive with its kind of treatment of the internet, and there's no way of knowing kind of how far that will go. Like talking about the specifics is very very difficult because like there's no way of predicting how these authorities are going to manage the internet. But like having a fully, completely internet independent solution, I think is the best way of making sure that you're not kind of any kind of threat that they pose to the internet channel is kind of has a redundancy. There's an alternative option.
So to summarize from the practical perspective, so this all functionality looks like it's very hard to operate like today. Let's say last year I had a real case scenario that I went to a remote Indonesian island and I had to pay for a hotel there. And it's very expensive to send the money to Indonesia. It's like you send $100 and because of the banking fees and all the exchange fees, the owner receives $75, so they charge like 25%. And I asked the hotel owner, would he be okay to receive a Bitcoin payment? And he said, of course, I would be okay at anything that saves me this 25% on the banking fees. But the problem was that there was absolutely no internet connection at that remote island, no internet and no also like phone connection. That to speak on the phone, you need to take like 2-hour motorcycle to another village. And he said, yeah, I would be okay to receive Bitcoin, but there's absolutely no connection. So from your perspective, like with all these technologies, what could I do like to pay myself and to help this hotel owner to receive Bitcoin transaction? Like, do I have to carry the satellite dish over there and the bunch of GoTennas? Let's say I'm unlimited resources and I can carry all this stuff with me. So what would be the solution in this case for today?
I think the demand has to come from the receiving side. Like they have to want to verify that transaction.
Okay,
they're not going to trust your verification.
Yeah, let's say there is a demand. What can they do and what can I do like today to do this kind of thing?
So I mean, like part of the way that this technology is going to roll out is the same as any other technology. It's going to start with the early adopters. It's going to start with the hobbyists. Right now, I'm not going to lie, the Blockstream satellite is pretty difficult to set up. But I mean, anybody in this room is capable of doing it. It just takes time. And the people, like for example, we'll be launching the Blockstream kits. The people that are kind of like willing to fork out for kind of getting involved early will help fund kind of development to improve these solutions and also provide feedback on what works and what doesn't. So like we have to bear in mind that like this is early, it's going to be difficult for a while. The people that most need it will use it, or the people that kind of are just interested will use it, and they'll help kind of bootstrap the improved solutions which will come later. As well, like we have to understand that right now there's not a huge amount of demand for it. The Bitcoin economy is still quite small. When people get cut off to the internet, it's not a big problem that they can't access Bitcoin for now. But as Bitcoin adoption grows, these kind of offline redundancy solutions are going to become increasingly important.
Since we're talking about restrictions and ways to stop transaction, do you know about the FATF rules that are going to be implied?
I'm not particularly familiar with them. I have heard that they're going to cause some issues, but yeah, I'm not particularly familiar with the specifics. do you have anything specific to kind of?
I was wondering if a system like that could be used to not apply to their rules.
You're going to have to be more specific with the question.
Well, Rule 5 implies that you have to have wallets, for example, who deliver information on whom is making the transaction.
Oh, right, okay, yeah. I mean, like,
so
we don't know that these are definitely going to get implemented and how effective they are going to be if they are implemented. I think in situations where people might want to use offline solutions, they're not planning on complying because they're potentially in like a really desperate situation with a really bad authority, or they're in a disaster situation. I don't think issues like that are going to be top of their priority list. I think what you're talking about is a greater threat to Bitcoin in general rather than offline transaction methods.
So this is it. Thank you very much to Woodfine.